Welcome and thanks for your interest in the Qu4lity Open Call. This is a registration of the webinar dedicated to the Open Call that we hold on 23rd of June. The registration started with some delay, so first minutes of the talk by the Qu4lity coordinator Jorge Rodriguez are missing. This first slide includes the agenda of the webinar and a short introduction to the project. Anyway, the relevant information about the open call is included later in the deliverable. Thanks again, and we hope to see a lot of application to our open call.
Want to implement the autonomous quality concept, that is basically to take into consideration the quality control not only at the end of the manufacturing process, but to have an end-to-end approach. We aim also to enable manufacturers and solution providers to adopt innovative solutions in the manufacturing, zero defects manufacturing domain. Next, please. Which are the key outcomes of the quality project? First of all, we are to introduce or to produce digital enhancements, not only in the equipment, but also in the manufacturing processes. We are producing a reference architecture and blueprints for integrating autonomous quality in the factory, and we will enable the production of different manufacturing platforms based on our digital enablers. And finally, we are going to run a pan-European innovation ecosystem. That's what we call the virtualized digital innovation hub. We will see that later. Next one, please. Regarding the pilots, we are going to demonstrate the results of the projects in 14 different pilots. 9 of them will be focused on improving the manufacturing processes, and other 5 will be focused on improving the actual equipments. Okay, you can see there the different companies. And finally, next please, thank you. And finally, we will also count on different testbed facilities to test the results before going into the pilot. And there you can see that we have different experimentation facilities from some of the partners of the consortium. So this is more or less the summary of the project, and now I will give the floor to Carmen to go ahead. Thank you.
Thank you, Jorge. One of the tools that we have in Qu4lity to create our ecosystem is also the open call. This is the first one that we have launched. And in line with the scenario presented by Jorge, what we would like to reach with Qu4lity is helping manufacturing SMEs SMEs and not only SMEs to improve the autonomy inside the factory. It is well known that with the technologies provided by the Industry 4.0, that more and more equipment and process are capable of taking their decision. There are many cognitive solutions that make this possible. The scenario that we envision with the Qu4lity is to reach the autonomy level 4 for zero defect manufacturing. This means that equipment and process are able to be autonomous and have cognitive processes, but decisions are always supervised by humans. So our scenarios is the one where we see collaboration between human and machines. To recap a bit the tools that we are developing inside the project for getting to these results, we have trusted digital infrastructure provided by the partner that appear in this slide. Plug and control manufacturing equipment and i.e. artificial intelligence powered digital automation shop floors. Another important point is in the way that we envision the quality is that we would like to have an holistic view on along the quality value chain. As you can see in this slide, along the value chain of the manufacturing process, there are different aspects where quality can be checked and controlled. And we would like, with the pilots and also in complementary with open call winners, to cover all the quality value chain, to test a solution and demonstrate in each part of the value chain, and also to make evident the connection with the other steps. In this slide, apparently complicated, is a resume of the autonomous quality control model. This workflow is the workflow for the quality control. While the project quality, it is interested in the blue square that you can see on the left. These are the elements that you need to introduce in your manufacturing process to get to an holistic integrated quality control flow. So one of the things that we will require to open call winners, it will be to align with this control model, making evident which one are the new elements, the cognitive elements of the digital infrastructure that you add to your process to make it more autonomous and to reach a better quality. Getting into a little bit more in detail about the call. The call is now open for reception of a proposal until the 7th of August. The evaluation process will be done during August and September, and hopefully we will announce the winners by the second week of October. The idea is to start right away in November, December at latest, and the experiment will last 9 months. If you have already checked the documentation we have shared, you already know that we have two types of call. The type A is the objective of having a new autonomous quality pilot that will be a complement to what we already have in the pilots inside the project. Here, the scope is to validate the quality concept, use and validate the digital enablers and technology, if possible, in areas beyond the pilots of the consortium partner. Proposals will be required to be aligned with the reference architecture and with the concept of autonomous quality. Here in this type A, we have 6 topics that we will see very fast. This is information taken by the guide for applicants. The first one is data-driven artificial intelligence for partner recognition in zero-defect manufacturing for high-performance product. So here we address companies that produce high-performance product, and the idea is to use the algorithms by artificial intelligence to recognize partners that could be used for to defects, to detect and prevent defects, and achieve proactive quality control, reverse engineering for this kind of product. The second one is related with robots and human-machine collaboration. Topic A2 is data-driven artificial intelligence, human-machine collaboration for zero-defect manufacturers. As you know, the collaboration between machine and robots in manufacturing provide many benefits in terms of productivity, safety, and also support to decision. Here, the goal is to demonstrate the potential of this human-machine collaboration for quality control in manufacturing, developing autonomous learning or decision-making algorithms, keeping into account also that the presence of human for supervision of intervention in case of emergency or something not correct, it is required. Then we have topic A3, integration of data-driven inline autonomous quality in solution for zero-defect manufacturing. Here, the idea is to have pilots of quality solutions that are integrated in the shop floor at the end of or during the manufacturing process. The idea is to have this autonomous quality solution that can deliver learning and adaptation capabilities to manufacturing companies. For example, in the case of scale-up from small or big lot size, or when there is a need to change between manufacturing process, with the need to maintain the required quality. So the idea is to apply this data-driven inline autonomous solution, quality solution in flexible manufacturing line. Then we have ensuring quality management in supply chain to blockchain-based technology. This is related with one of the enablers that engineering has made available for this topic. We will see it later. So here the applicants are required to develop novel distributed applications to control quality and traceability of material and products along the supply chain using this blockchain-based enabler. Then finally, integrated zero-defect manufacturing solution in mass customization and lot size 1 manufacturing process. With the technologies enabled in the last few years, it is more and more easy to let the customers to customize their product, to have with ad hoc features. And also, it is more and more common to have the lot size 1 manufacturing processes to produce just one piece of a certain product. Keeping the quality at high level in this kind of situation is challenging. So this is what we would like to address within this topic. Regarding the conditions, a proposal must address, participant must address one of the topic listed before, and well, it is possible for some applicants to have a certain overlapping between two or more, but anyway, they have inside also the tool for submission to choose one, their main topic. They should use the quality digital enablers or technology that we will see later, but anyway, they can include other technology as soon as they are aligned with the quality reference architecture. Then final solution should be integrated in the project market platform. We will see the details of what this means also in terms of intellectual property with at the end of the webinar. So we have here a budget for 4 proposals. We will have more in the second open call, and we expect to be submitted by a single applicant. The type B type of call, it is related to the expansion of quality pilot systems. Here, the applicants are not free to choose one of the topic, but they have to reply to a challenge launched by our pilots and propose a solution. And then they will have to interact with the pilots and implement with them the solution provided. Here we have, in this first open call, just one challenge launched by Whirlpool that it is included in the guide for applicants, but we will see also later presented by Whirlpool by himself. Here, the solution proposed should contribute to expand the quality ecosystem, broaden the solution quality portfolio in the market platform as well. For type B, the same solution that they should align to the quality reference architecture, and they will have to put their solution available through the marketplace. The budget is for one call, because we have only one challenge, and it is 75 kilo euros. And also here, proposal must be submitted by a single applicant. These are the eligible costs. In this sense, also for the evaluation, we follow the rule by the European Commission. So eligible costs are personnel, equipment, travel expenses, software license, subcontracting, and indirect cost. We are in innovation action, so the rules for funding are the same applied for inside the consortium. This means the SMEs will receive it max 70% of the cost. Both type A and type B are open to SMEs and mid-caps. Other kind of entity are not allowed. This is because, as one of the things commented at the beginning by Jorge, is that the solution are not easy to reach SMEs. That's why we want to address especially them. Just one thing, this is important also when you prepare your plan, your work plan, that you have to align and include this deliverable. Align with the 3 levels of maturity. We expect you to get to maturity level 1 at M2, where you have to, for type A, have a proof of concept, alignment with reference architecture, and with the quality, autonomous quality concept. And while for the type B, you have also to have an integration strategy in the reference pilot. We expect for M7 to have the complete development of the project, and for you to show us a demo and dissemination material. We will see, according to the evolution of the situation, if these demo days will be remote or a physical meeting. And then at the end, the last 2 months is to prepare the business model, the integration with the marketplace, and the business plan. Okay, so we will go inside the technical aspects of the project, and we will start seeing the reference architecture that will be presented by Angelo Marguglio from Genius.
Yeah. Hello, everyone. I'm Angelo. I'm the technical coordinator of the project, and I'm following specifically the specification of the reference architecture, as well as also some other activities within the project. I will go quickly through the main, in some way, ingredients that have been used to develop this architecture. So, as already commented by Jorge and by Carmen, we are building this bunch of solutions for AI-powered tools to be distributed along the whole value chain, of the data value chain, from the shop floor to the business application, building on top of the pillars already mentioned by Carmen. First of all, digital infrastructure. The second one is the equipment that has to be enhanced, and then the third one are the processes and application for digital automation. All of these three ingredients have led us to better define and analyze the 6th level of the classical scala pyramid, and especially which is the best tools that has to be enhanced by AI-powered solution for the data collection from the field to the cloud, especially for the planning phase, and then for the autonomous control loops that have been mentioned that can be realized in different level of the pyramid. So some control loops can be closed directly on board on the equipment, some control loops can be closed on the edge device, some control loops can be closed on the cloud. Next, please. To design this reference architecture, many standards have been identified. You know that in the manufacturing industry there are a lot of European and worldwide standards. Some of them are derived by consortia, and some others are open platform and open standards provided by some European initiatives like FIBRE, like International Data Space Association. And we're trying to take the best of all these initiatives, and we're trying to build our solution, obviously not from scratch, but using these standards and using the results of the previous FF11 project, and specifically from the Digital Software Alliance. And starting from that, we have defined and specified our architecture and then the blueprints that we are now using to implement our pilots. The main pillars that have been used, and now we will see how all these pillars have been in some way just postponed in order to create our architecture. There are a lot of, I would say, classical solutions, classical technologies. Some of them are already mainstream, some others are not yet mainstream, but there are a lot of background knowledge from the consortium partner, but a lot of activity that is going on in the project lifetime. And the main, in some way, layer that we can identify are the networking and fast connections to support 5G and other technology on the shop floor. Edge technologies, again, for distributed computing, but also for the industrial IoT enhancement, starting in both brownfield and greenfield approach. And we have a lot of solutions for the cloud, big data, and the HPC stuff. And then also some sort of transversal of the cybersecurity and security framework that has to be obviously enhanced in order to support AI data processes and tools to be distributed all over the pyramid. All of them are obviously, next please. All of them actually have been integrated in this one slide piece in order to describe the overall architecture. It is one of the outcome of the project. I mean, on the first part of the project that the Open Code winner has to use, as already has been mentioned by Carmen in the first few months. Sorry, you have to adhere in some way to these architectures to figure out how to map your expected solution, your technologies, and the enablers that you will select from the list that has been mentioned. And now we will get more details on them in order to fit this vision in terms of how to interconnect the different tools and processes, and also how to interconnect this with the autonomous quality vision. I will not go into much details, but as you can see, we have on the right side the digital infrastructure, so coming from the networking, for the edge, from the cloud and HPC, and also the ledger technology on both private mode, but also on the supply chain mode. You will find all this infrastructure as a sort of enablers that has to be obviously mediated by this security middleware, and then enabling a lot of services and processes on the left side of the picture. So again, on the left side, we'll start from the smart products, from the enhanced equipment on the lower part of the picture, and then going up, you will find several services that can be distributed from the edge to the cloud. Some of them are for fast connection for console services. Some others are indeed for a more industrial oriented way of data exchange and processing, again at the edge, and then going up toward data-driven digital twin and simulation, and then on the, I would say, process like multi-scale DDM processes, user-centric, and adaptive digital automation. In most of these way, we are adopting some standards. I will not go too much in details, but we have also these digital models and vocabularies that are an outcomes of other activities within the project. And it is why we are trying to also easy, which is the best way to connect the data, to extract data from the different level of that data, and then how to put them available of the different services and applications. Next, please. As mentioned, one of the requests of the open call winners will be to map toward this architecture. So you will get obviously some more information during your experiment lifetime. But the idea is then to try to map your tools, your technologies, and your processes in respect of this. So obviously you will find something like you can see here, so a sort of questions that can help you identify how to map toward the architecture. Next, please. And you will obviously just say create the right mapping and provide the full details again on your technology and your processes. But again, this is something that will be better clarified during the execution of the experiments. Next, please. Okay, so I'm done.
Okay, thank you, Angelo, for this clear explanation of the, I hope, clear for reference architecture. Then we can see now the enablers. We have 3 enablers. The first one is Karma, presented by John Soldato from Intrasoft. We can go a little bit far.
One of the enablers that we offer to open call proposers and of course to open call winners is the Karma enabler. It's actually a machine learning or artificial intelligence framework that you can use in your quality management experiment. It's a framework for mining of large industrial data sets, which we can use to identify rare events like the machine failure or a defect or a correlation between a defect in your product. So it's the library is already validated in different settings, including industrial use cases, and of course we use it in quality, but also in past projects. So the main principle of operation is that Karma is a set of tools that can allow you to extract rules that identify anomalies or unusual events and allows you to select the rules that have the highest confidence of being true. It's also a parallelized set of algorithms, so the implementation is parallel, which means that if you want to use it in parallel hardware for high performance, this is possible. The added value and the reason you may want to use this machine learning framework instead of taking some standard machine learning or deep learning algorithm from the literature is, on the one hand, the ability to extract high confidence rules even on events that occur rarely in your data set. On the other hand, because the output of the framework are rule sets, it means that the results are also explainable, which is very important for the quality management stakeholders like the plant operator or the maintenance engineer to trust the result and to accept to deploy this in the platform. Maybe the next slide, Carmen. In principle, how to use it in your open call experiment. Again, this can be a machine learning option in addition to the other systems that you may want to employ in the experiment. But one thing that is a prerequisite here is to have some proper industrial data set. So like data coming from a sensor or a tool on your machinery or on your production. So these will be used as the input to the Karma machine learning framework. And on the other hand, the output is as it's going to run, you will get some predictions and calculations on parameters like the remaining useful life of machinery. From our experience is that you need to have a significant data set. Of course, we talk about big data here, so it won't work well on small data sets. But of course, what we really need is a few thousand endpoints. When you have sparse data sets in terms of your input, this has proven to work very well and probably better suited than having fully dense data sets of all your features. Now, to use this Qu4lity machine learning framework, we are going to give you a REST API. So this is going to make it easy for you to use as a standard development practice, along, of course, with the proper documentation. This will be given not to the open call proposer, but actually to the open call winner when the actual implementation comes. I think for the proposal stage, but also for the winning stage, in the next slide we have some publications. Most of them are open access. They are project publications, but of course, if you want more information, you can feel free to contact us directly, and we can give you information. Of course, you're going to find the mechanics and the inner workings of the algorithms in these papers already. About the Qu4lity family of algorithms.
Good morning, everyone, from my side too. I'm Figenia Metaxa from Atlantis, and we're going to talk now about the enabler of in the what we call the rule metric, which is remaining useful life tool that we are making available for you through this open call of Qu4lity. So when we talk about the remaining useful life, we're actually talking about calculating, predicting with a level of confidence of what is the length from now to the end of the useful life of an asset. The useful life or the failure can be interpreted in many ways, and it depends on what is useful for your experiment. It can have the literal meaning, so it actually has to do with a machine that breaks, or it has to do with the damage on the asset or the violation of any standard that's related to the quality of the product, of the end product, or in the intermediate stage of this product. We can figure this out together. We will also offer some mentoring to the open call winners. And this analysis, you should have in mind that it provides the information about the deterioration rate of the equipment so that you can translate these results into actionable knowledge for the shop floor. So modify accordingly the maintenance activities and minimize any negative impact effects on the productivity, and be able to avoid any quality issues for the area of the case that you have used for the experiment. Next slide, please. So what do we do? We monitor, in essence, the deterioration rate of the machine. This equipment, every equipment, when it is in use, it slowly deteriorates, it slowly goes away from what is the optimal condition according to your sets of quality standards. But if you are able to predict what is going to happen in the near future, what are the issues that you're going to face, you don't have to act upon a problem, so in a corrective way, but you can act in a preventive way, and gives you time to schedule stops and avoid major failures and reduce downtime or increase time to repair. The algorithm itself, the tool that we offer, has an advanced-driven approach, pretty much similar to the digital enabler that we were discussing earlier by Mr. Soldatos. So it's based on deep learning, on what is widely known as the long short-term memory and complex event processing. And it relies on both historical data for training the first part of the model and real-time data for the online evaluation. Why have we selected to work with this algorithm? Why you should be interested in this? Because we can identify relationships among various types of sensors. So if you have on your subfloor various sensors, various parameters that you measure in your equipment, we can take them into consideration and allow to process different events from different types of parameters that you measure to train models and translate this into a picture of the health status of the machine. Next slide, please. Is it the right digital enabler for you? For which applicants is then this solution compatible, suitable? You need to have historical data, some sensors in place, getting now real-time sensor data, and very important to have log files with previous hardwares or quality faults. The name of the fault, the type of the fault, the timestamp. The better the information we have, the better the output can be. And if you have a correlation between faults and signal, so what is commonly known as the failure modes and the causes or effects, this is nice to have. Otherwise, we can work in a kind of a blindfolded way to be able to identify, detect these kind of events that are present in the data. What will you get is a Dockerized solution on your premises or remote location. Default parameterizations for the model training. We won't leave you alone. We'll start with you. And the ability to build custom solutions through the mentoring that are right for you. There's a generic approach for data fetching, and there are a lot of tools that you can use to put your own data. This has been actually validated in the quality framework and in the quality project, and in other projects that we are testing this data fetching mechanisms. And you will also get these data transfer bridges to be able to take advantage of your data. For making your data working towards improved quality and be able to produce better quality parts and be able to pinpoint any critical points in your value chain. Next slide, please. So the benefits, if we put it down into something more discrete, is reduction of operation and maintenance costs, increase of productivity and remaining useful life. So be proactive, be preventive, reduce downtime, reduce the mean time to repair, and increase the mean time between failures. So you will be able to test how tools like this can improve the availability of equipment and the health of your machines, so that you can avoid failures, breakdown, and optimize the production schedule and maintenance schedule. The main goal is that in the factories of the future, in a digitized environment, there's no need to leave machines get deteriorated, but you need to go in a more preventive point of view. I think that this is all for now. Maybe we can go then to Mauro. Thank you.
Thank you, Ifigenia. Then the last enabler, blockchain infrastructure, by Mauro Isaia from engineering.
Thank you, Carmen. Can you confirm that you hear me?
Yes, we can hear you.
Yes. So, good morning to everyone. My name is Mauro Isaia from Engineering Informatica. I'm introducing to you an enabler that is quite different from the others, because it is more like an infrastructure than an application. And it is a piece of infrastructure that is part of the quality reference architecture. As you can see here, we are talking about two elements, which are the value chain ledger, PCL, and private ledger, which is PL, and you can see them on the rightmost side of the picture. The difference between them, because they are both distributed ledgers, so blockchains, is that the value chain ledger is a common facility that is available to everyone in the project. And the idea is that it should be used by multiple stakeholders, but inside the same business ecosystem, which typically means a supply chain. The private ledger, on the other hand, is about a private blockchain instance that is deployed internally to a company. And the idea is that no information is shared with the outside world. So the uses are quite different. Next slide, please. The general idea is that blockchain in Qu4lity will enable the secure state sharing and synchronization of industrial processes, whatever. So it doesn't limit itself to zero defect manufacturing, but of course, in this context, we expect to be using blockchain exactly for this. And so we will have a smart contract that will be able to do a number of things. One example would be the centralization of control. So we have one process, but we have multiple autonomous actors. And all these actors can run without any supervision, without any central point of control. This is typically what we do with private ledgers. And we can use private ledger, for example, for implementing plug and produce machineries inside the factory. Another possible application of this infrastructure is the tracking of events, the trustworthy tracking of events. You know that blockchain is a distributed database where everything that you write cannot be removed or altered. And so when you write something there, it is a sort of non-repudiation statement. So if you sign it with your digital identity, it means that you are making a statement that cannot be reverted. And this is quite useful
for tracking supply chains, for example. Next slide. What we do provide on top of this infrastructure is DLT services. The DLT services are smart contracts. And in our case, we are just using the common instance, so the value chain ledger. A DLT service is not only a smart contract that runs on the blockchain, but it is also a package containing a client library that application may use to connect and interact with the smart contract. And so we can hide all the complexities of using the blockchain protocols of authentication, authorization, everything. It's just a library that replicates the API of the smart contract locally to your process. And in Qu4lity, we already have a library of DLT services that are generic enough to be employed in a number of different scenarios. And they are listed here: the Qu4lity Clearinghouse, the decentralized analytics engine configuration, and the secure analytics results publishing. As we are talking about supply chains mostly, and this is related to the A5 topic of the open call, we will look more closely to the first one, the Qu4lity Clearinghouse. Next slide. Thanks. The Qu4lity Clearinghouse is just a common system of record that is basically for a manufacturing ecosystem where the actors need to assess the quality of any parts, materials, and also final products. And these results must match the contractual standards that are defined for the process. And here we have a very simple example of how this can work. We have three actors, company A, B, and C. Company A is the manufacturer of the final product. Company B is one of the supply chains providers, so it's a manufacturer of parts. And also we have a third company that provides metrology equipment that is deployed by company A inside its own premises. The process starts with A, who defines the standard, and so they publish a record that is called the quality assessment model on the ledger, which is basically a quality assessment plan, which defines some indicators that must match for all the parts that are produced by the other manufacturers in the supply chain. Now, when B ships a batch of parts, there is another kind of record that is published there by B, which is the shipping union manifest, which is basically a bill of the shipment. And when A receives and processes the shipment, it creates an additional record, which is a quality assessment report that is based on the results of the quality assessment made by the equipment produced by C. Basically, this means that in the end, when the payment to B is due, any penalties and discounts that are defined in the plan for missing quality targets are documented there. And so also we might have optionally an additional use of this distributed ledger so that the A may pay company C for the actual usage of equipment, basically on a paper use agreement. So this is the overall description of this particular smart contract, but the enabler is not the smart contract, it is the infrastructure. So the message is that if any open call candidate has a plan on how to use the blockchain infrastructure for implementing a distributed process, a decentralized process, please contact us, and me in particular. I'm afraid there is not my contact in this presentation. This is a mistake, sorry, but we will add it in the version that will be released. Contact us because we can see together if we can help you in implementing a custom smart contract for your needs. If this is not, if the quality clearinghouse is not what you expect. That's all from my side. Thank you very much.
Okay, thanks. Yes, we will add the contact detail of all the speakers, and we will share the presentation because I see in the chat that someone is asking about that. So now we will see the Type B challenge. We are with some delay. Anyway, I think that we will finish around in 10 minutes, no more than that, and then we will give space to your question. So, Pierluigi from Whirlpool.
Hello, can you hear me?
Yes, very well.
Great. Very, very briefly so we can recover some time. One of the pillar of Whirlpool use case in quality is the adoption of a way to link the quality perceived by the consumer to the components and the process that are used to make our products. The key to link the quality, for example, how an appliance is noisy or how is performing in the drying or in the washing functions, is actually to describe the function that each component is performing inside the product. So we started with this approach that we call material process function quality that we developed actually initially in another recent FP7 project, but we are now working to let it more develop, more evolved. Okay, what's the challenge here? Is that, of course, we should have, in order for the quality technician, quality managers, and engineers, we should have a tool, a graphical tool, able to build those kind of mapping. Because, of course, it's very important to have a help to let engineers, starting from the bill of material of their products, to define all the function that is each components are changing, and build this kind of relationship between material, process, and function. Currently, in this project, we are using a graphical interface like Lucidchart or Excel, but of course they are not enough. What we are really working for is an editor system which is able to sort of a computer-aided design, if you want to take it that way, able to allow, or better, the engineers to build those maps, to classify the components according to their families, identify all the functions, identify the different types of components that could be part of the product itself or external components that the product has to interact with, and of course having those maps being able to be transformed into a machine-readable format. In principle, we would like also to have this kind of graphical tool able to automatically make some code generation in terms of, for example, database columns and tables generation. That's in principle what we are looking for. To summarize, I use a graphical interface able to take the rules that will be, of course, detailed, has already been presented in some scientific papers and will be detailed furtherly in the next weeks, and let the engineers to provide these insights and connect directly with the rest of the architecture. If there are some answers, I'm able to be able to understand.
Gigi, can I add one comment?
Yeah, sure, Claudio, go.
Yes, because we developed, as mentioned Gigi, this modeling, material process, quality, function, and quality in the GRACE process, GRACE European project. And during this project, we focus our attention regarding the generation of function, because there's a different way to have the perspective regarding the quality of our appliance. Our appliance is under the control of the customer. The customer doesn't matter which kind of process, which kind of methodology we use for build, for assembly the appliance. For our customer, it is important to understand if the appliance doesn't have noise, if the appliance has a very good performance in cooking, in draining, in washing, and so on. Using this kind of model, we mapping how any kind of function that is the hand of our customer has generated. And the concept is, if our material process and function in terms of full methodology that our plant is based is fully under control, it means that also our list of quality features are under control and our customer is satisfied. So in order to generate this chain of elements, the one connected to the other, it's let me say, is crucial for us for defining this kind of model, a tool able to link every part of this modeling, considering also the mapping of the process that we have in the assembly line, considering the mapping of the materials, and also including for material characteristics, process characteristics, because it's very, very important to understand that maybe the setup of every tool, every equipment that is performing the activity of generating the function. Also understanding all the data that we are collected are not more analyzed, the data quality analyzed in terms of black and white, but to understanding if our production is under control. So it means that we are all the quality, the list of the quality characteristics are well fit. They are well fitting the goal for us to provide to deliver appliance having very, very good and high level performance for the customer. This one is my contribution. Okay. That's all from my side.
Cici, do you have something to add, or it's okay this way?
No, that's enough.
Okay, thank you to both of you, and so fast to the last presentation about the concept and about the quality market platform. John, please. John, are you there? We can't hear you. You are muted.
Yes, I was muted. Okay. I'll now present you the Qu4lity market platform or marketplace, if you want. One of the objectives of the Qu4lity project is to create a community around the project results, what Carmen called earlier on Qu4lity ecosystem. So one of the vehicles for realizing this is the creation of a market platform. We call it a virtualized market platform in the sense that it doesn't have physical existence, but it's actually a collection of distributed resources by different providers. So in principle, the market platform is a platform which serves as a single access point to all the results of Qu4lity, including the digital enablers like big data platforms. We have machine learning and artificial intelligence algorithms, but also turnkey solutions like pilots, experiments, and of course any additional complementary assets like trainings, methodologies, and so on. So this is a high-level structure you can see of the figure of the virtualized market platform. And in the next slide, just a few words about how this is implemented. Actually, we have already an implementation. What we are planning to do in the coming months is we are planning to do the public launch of the marketplace, so the market platform. So of course, it's not developed from scratch, but is based on similar efforts like DIH Word, and we expect to have a public launch in July 2020. Now, what does this mean for the open call participants and the open call winners in the next slide? So, as you have seen in the presentations, in the previous slide of the presentation, with the terms and the conditions of the open calls, we expect each of the open call experiment to help us grow the marketplace, the market platform in terms of content, but in terms of community. So we want the open call proposers to clearly outline what is the result the results that they will be produced, which can be made available through the market platform. You can read also instructions about this in the open call text. So we expect, similarly to what we do in the project, we expect open call participants to propose, to provide to make available in the market platform digital enablers or solutions, or even other complementary assets like methodologies, blueprints, and so on. So this is going to be the proposal stage, and we expect to have from each open call proposer a value proposition with respect to Qu4lity in this front. So how you can support the market platform with new content, and also in terms of community building. Maybe this might mean something for your impact creation activities, dissemination, exploitation, and so on. Then from the winners, we will actually expect to provide what was promised in the market platform. So this, as a minimum, means for every asset created and made available through the market platform, a market level description of the result, a proper packaging of the result. So for example, if it is some software result, we need some standard way of distributing it and accessing it, like you can imagine a Docker image, and of course relevant documentation in the form of presentations, manuals, demonstrators, one-click demos, and so on. Needless to say, we would like all open call winners, but also open call proposers to register in the marketplace and help us grow our community. Finally, in the last slide, Carmen, one important clarification about IP. By integrating into the market platform of Qu4lity, it doesn't mean that you are releasing any part or any share of your foreground IP to the project. No, this is not the case. So the market platform is is basically a promotional channel, or if you want, one of the promotional channels of your results. So what we want is actually the description of your asset and the ability to distribute, the right to distribute your asset through the market platform. It doesn't mean that the Qu4lity project or the Qu4lity partners gain the IP of whatever you develop. So we want to be clear on this. So it's a clear win-win situation, because we give you the means to promote, to disseminate, and to exploit the result. And of course, you support us by growing our community and by making the content of our market platform richer. So it's clearly a win-win value proposition for our project, but also for the open call participants and the open call winners. And they do not hesitate to outline, to describe what you are going to make available to the market platform of Qu4lity, and how you intend to support us, grow our community, while you get benefit from promotion, dissemination as part of our activities and channels. And that was all about the market platform in the scope of open calls.
Okay, thank you, John, and thank you to all my colleagues from Qu4lity for this presentation. I will stop share, and we can start with a question and answer. If you don't mind, I will please first start from the questions that are already here in the chat. Okay, so we have already, I think that the first question, will the slides will be available? We have already clarified that this is will be done. They will be available on our website and also on the EMS, where the website for a application. And then we have, can software SMEs apply for Type A having support by a pilot factory with a letter of intent? Well, in Type A, you have to provide a pilot. So the ideal candidate is a manufacturing SME. In principle, software SMEs, yes, can apply, but they have to demonstrate their ability of carry out a pilot in a manufacturing company. So maybe a letter of intent is not that much. The manufacturing company will be a better applicant for the code, with some subcontracting, for example, to a software SMEs. Then is there a target TRL for the experiment of the open call? No, we didn't define a target TRL, but anyway, well, you have to you need a certain level of technology readiness to get to a pilot, and this will be evaluated by our independent experts, even if not, we didn't define TRL for the experiment. I don't know if you, John, or you want to add something that maybe this can be relevant for the market platform.
Yes, the Qu4lity project is an innovation action. So in principle, we seek solutions that should be operational in a realistic setting, right? In a pilot environment. So, for example, if you join the type B open call, it means that what we develop is ready to be on a pilot line or in a real production line. So although we don't quote explicitly specific TRL level, you can assume from this description that we seek solutions that are over TRL 5, 6, up to TRL 7. Now, with the connection to the marketplace, of course, ideally we want a market-ready solution. We don't want just research prototypes, right, in the market platform. Again, we don't restrict, we don't exclude a solution by TRL level, but we silently assume that we are talking about solutions at TRL 5 and above.
Okay, so here I see another question from Eva. Can quality system producer apply for the call, so contracting a software company for the integration with quality enabler? Quality system producer, I'm not sure what it is. I don't know if Eva is still connected and can clarify.
Yes, Carmen, I'm still connected. No, I'm thinking about a manufacturing company which is producing a quality system with vision systems embedded and robotics arms for making accurate, different types of accurate quality controls on components. Mm-hmm. So they own this system, and they want to enhance with some artificial intelligence to enable better interaction with the worker, and also a pre-analysis of data of components that has to be inspected.
Okay. Yes, I think they can apply. So contracted is allowed, but remember that you have to develop a pilot. So you will probably need the manufactured SMEs, or if you have an internal experimental facility, so also this can be acceptable.
Yes, sure. They have a sort of shop floor where they can do the experiment, but I think that they can collect a letter of support from a customer if this is sufficient to do the experiment.
It is sufficient to apply. Then, of course, this should be valued by the evaluation team and compare also with others. But yes, I think they can apply.
Okay, thanks.
Thanks. So another question. I would like to know if the same entity can submit more than one proposal. Yes, but cannot win more than one. More than once in case, but yes, it is allowed. Do you have any restriction with other calls, for example, CE or I4MS? No, for our call, there is no restriction. The main reason also, probably who knows about the open call system know that there is a limit for generally 60,000 per participant. In this call, from the work program, there is you are allowed to get some more because there is the development of a pilot. That can require something like equipment, so it is a little bit more expensive than a simple experiment. So this should be very well justified in your cost, especially in other costs. You know what kind of equipment and solution you need to buy, but there is no the limit of 100 euros. There is for CA and I4MS. Then the deadline is July 10th. Eva Kessisoglu asks, while the submission tool is August 7th. The correct is the last one, August 7th. There will be some delay in the open call due to with the COVID and other organizational project. So a question for Type A proposal. Does the amount refers to the total budget or the funded part? No, 7,250 key euros is for the funded part. So the 70% of the total budget. This is the question from Kaliroy. Another question for the Type A. How many enablers, technologies, a proposal expected to employ? Are the digital enablers connected somehow to the topic mentioned? Okay, it is required to use at least one. So 2 of the digital enablers are generic enough that can be used with all the topics, while the enabler provided by engineering is connected to the topic A5. Then a question from Joao, is it possible for the SME to subcontract a technology provider or academia for the development? Yes, this is allowed. Max external cost subcontracting. In principle, there is not a maximum for subcontracting, but this is also something that is going to be evaluated. It should be reasonable. I mean, part of the development can be subcontracted, but in a reasonable quantity. I can give you a percentage, but it should be well justified inside the project. Can you confirm that you allow subcontracting of software development that we will build up the experiment? Yes, in case if we are talking about the manufacturing SMEs that subcontract some software development, in principle, this is allowed. I don't know if there are some other questions. Also, you can talk if you prefer. Okay, 30 seconds more if someone has some last minute question. Okay, looks like there are no more questions. Anyway, you can, there is an email and there also a contact tool inside the application. So in case you want to have more questions, you can always contact us. I would like to thank you everyone for the interest in the open call to assist to this webinar, in particular to my colleagues from Qu4lity. And thank you, and I hope we hope to receive many applications. Thank you. Bye.
Bye-bye, thank you.
Thanks, bye-bye.
Bye.
Cheers, bye.
Thank you, bye.